Hey everyone. Yeah, so before we get started just going through the EC2 example, let's actually just talk about what a security group is and then what a network access control list is. So a security group is stateful. I'm sure you've heard that term millions of times. We're going to go over what that means. But stateful just basically means is that the stateful firewall is going to look at the connection as a whole. It is going to see that the connection is open, whether it's like since synchronized, synchronization acknowledged, established, what have you. Whereas stateless only cares about individual packets, and it only cares about like its source destination, port, and IP address. That's all that really matters. And that's going to make a lot more sense as we go through this. So let's continue on, and what we're going to do next is we're going to go through and just make this example for myself easier. We're going to create two EIPs, which you can do this here, or you can do it over there, but actually let's just go to EC2, and let's go elastic IPs. Foreign, I see that I've already created two, yay. And how you do that, super simple. All you gotta do is just click on allocate elastic IP addresses, and you get to choose some. And you have some additional options here for people who are paying a lot more money than I am. Okay. All right. Next, we're going to create two security groups. So let's just go down here to security groups. And I see we already have one called all traffic. You know what? We're going to keep this one because this is exactly one I need for this. And also, all traffic, nothing suspicious. It's all good. So we're actually going to call this one foreign server group. Foreign server group. And as far as inbound rules, we're just going to say right now, per example, all traffic is a go. Now you can see right here by default, outbound just allows everything. Oh, and I should say not all TCP, but all traffic. This is going to include like ICMP and other protocols. Yeah, we gotta include that too. All right, cool. All right, now we got that down, and now we're going to launch two instances. We're going to call this U, as in like us. And we're going to use like CMI2. Yeah. All right, we're going to keep this cheap. I'm actually going to use, yeah, that's more than enough. Unless I'm going to come down here and just like, just go wild. Like, yeah, I need this much. No. No, I have no idea how long this video is going to be. I don't want to spend like $20 just for one video. Okay, it looks like we already have one of these, but I don't know where this is at. This must have been a prior example from like way back when. So I'm going to create a new key pair, and I'm going to call this my key pair. Download that PIM file. But back in the day, you had to make your own PIM file. I don't know why you had to do that, because when you downloaded it, it was always a PPK file. I'm saying that right. And as far as network, yep. And we're going to select the existing group. This is going to be for us because like you're just going to be promiscuous. All traffic is going to go through. But also we need to make sure we choose a good subnet. And let's do A for this one. As far as space goes, storage. Nah, I don't need too much from there. Okay, let's do a quick review. AMI2, 64-bit, T2 micro, new key pair. Awesome. Yep. And down here we can do some more stuff, but it's not really necessary. Like I have no user data that I'm planning on using. So we're going to launch this. Done. Okay. And we're going to launch another instance, which I know we can launch multiple, but When you're launching multiple, you can't specify different subnets, and that's going to become important later on in the video. So now we're going to create another server called foreign server. This one's going to be AMI2 as well. And I'm not choosing AMI2 just because it's something special. It's just one I'm familiar with. This one's relatively new, and I'm sure in the future I'm going to use this one more heavily. Okay. Now we have a T2 macro. Yep. Key pair, my key pair. Did I actually download that? Yep, I did. Awesome. And then select existing security group, foreign server. Yep. Oh, and we got to change this to, yes, I have a preference. Let's put this in an easy one. Let's put this in 2C. All right. I think we're looking pretty good here, and let's launch. Okay. We have 2 instances. Let's see if they are actually running. No instances. Yeah, it says 2 instances. Any state, there's no filter. All right. Yeah, again, that's cool. Great. So the reason why I have 2 EIPs that I made earlier is just because I want to attach them so it's easier to remember who's who. So let's associate, and in case I have to stop any of the servers for whatever reason. So let's associate you to you. Yeah. Now let's take foreign and let's associate this with foreign. Okay, awesome. Because I have another script here that I am going to copy this over here. And I think, yeah. I'm gonna have to mess with this one. You. Like that. And foreign. All right. Cool beans. Okay, we got those up and going. Next we need to do is actually log into these hosts. All right, we're going to be using PowerShell. And I know, I'm using Windows. It's not a big deal. I'll be using Mac in the future. Maybe. But continuing on, we need to get this. We're going to SSH into it. EC2 user at for n. And we're going to do the same thing for the foreign server. Here. Okay. Next, what we're going to do is you're going to make sure that when we log into this machine that we know exactly who this is. And we're going to come here. And copy that. And if you're wondering what this does, we're going to get the metadata and we're going to get the public IP address. And they're going to put in here. And so in the prompt, you're going to see the name of the user and the IP address and the fact that it says foreign server. Bash RC, like this. Okay. And also because I did actually turn this setting off, but I'm going to show this here to y'all. So this is new. Yep. vi.bashrc. Insert source.bashrc. If you ever run into this issue right here, what you need to do is just come down to instance settings, modify, and change this to optional. Then we can do source again, and there you have it. All right. So I think I might have explained this earlier, but we're going to be using netcat, which is just a utility for debugging TCP and UDP connections. So let's go ahead and do our first example of these servers communicating to each other. Okay. And so in order for it to communicate, we're going to use sudo nc-l, and we're going to use port 80. Now we have to use sudo with port 80 because you have to have admin access to try to occupy that port because it's such an important one. So the foreign server is now going to be accepting TCP connections to it. And we're going to do nc, and we're going to get the server name or IP address. Rows. As you can see, we are now connected. Hello, Dylan. Sup, John. Okay. And if you remember, let's go over here to security groups. Everything right now is just open. All traffic, accepting everything. Open, 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 open. That's what we have right now. Okay? And let's also do the flip reverse. So now this one, nc-l 80, is going to be accepting TCP connections. And this one is going to try to communicate with it. And we're going to do 80 for both. Hey there. And as you can see, there's a simple connection. All right. And that's with everything just being open. It accepts all traffic, inbound, outbound. It's good. But let's do an example where the inbound is close to everything except SSH because I still need to be able to get in there and do stuff. All right, and the only security group we're going to be modifying is just the foreign server group. So let's come here, foreign server group, edit inbound rules, and we're going to change this to just SSH. I know it looks a little bit funky right now just because of how it's situated. But let's see if we can make it a little bit better. There we go. All right. I'm also going to kill that connection. Cool. It's just SSH now. Everything else is disallowed. So still have good connection. Great. All right. Let's try connecting to this one again. See what I was talking about? All right, server's up. Let's try making a connection. And I'm going to add a timeout so we're not waiting for like 10 seconds. Okay, as you can see here, it was timed out. So this is coming inbound. Now, how about we have us, or you, accept the connection. Let's see if that works. As you can see, we are connected. Hello there. Now, why is that? So if we come over here to the foreign server group, the inbound only accepts SSH connections, but the outbound accepts all connections. So this is like, imagine like where it starts at, that's where it matters. Like where does the connection begin? So when it says outbound, it's like when this server is making a connection out to something, okay? That's allowed. All traffic where the origin is coming from that server, that is allowed. Now, if there's stuff trying to come in to the server, that's disallowed unless it's SSH, okay? And if you remember, for us, or the U server, all traffic is permitted, so that's never going to be a problem. Okay, now let's switch it up again, and let's make the inbound open, but the outbound closed. The foreign server group. So we'll just leave that there. And we're going to say all traffic. Outbound. And we're just going to say well, I can delete this, but I'm pretty sure there's like some issue where it immediately, yeah, it kicks me out. It's now frozen, although this is not necessary. I don't know why it does this, because it will come back up where it will let me connect to it. Okay, let's go to downloads. Here's -I be my the EC2 user. Works like a charm. There's probably just some, saying to connect, connection reset. Yeah, let's just use this screen and clear. Okay. So same operation. Now let's do this hosting again. Let's try connect. As you can see now, there's a connection. So inbound's open for this server, but outbound's closed. Remember that. Hey there. How are things? That works. Okay. But now let's actually host the connection on the U server. Okay. Now let's try and make an outbound call to another server in port 80. Let's see how that works. Connection timeout. It does not work because it cannot make any outbound calls whatsoever. So effectively TCP/IP, it's not going to be able to make a connection. Okay. Next thing. Okay, let's next talk about Network Access Control List, or NACLs for short. We're going to come to here, go down to security, change security groups. We're going to remove the foreign server group, add all traffic. And the reason why we're doing that is because we don't want the roles from the foreign security group to affect what we're going to be doing with the NACLs. And we're going to come up here, type in VPC. Come down, not to NAT gateways, but to Network Access Control Lists. And you can see there's a default one with the 4 default subnets already associated with it. And we're going to create another one We'll call this foreign. Create. And NACLs are associated with the subnets themselves. So any EC2 instance that happens to be in the subnet that's associated with this particular NACL are going to have these rule sets applied to it, which there's nothing really except the default. And let's talk for a second how NACL rules are actually, the system works. So NACL rules are evaluated in order from least to greatest. So when we're creating rules, we have to number them. So this would be 1. We got another one like 2. And we'll say that all traffic is allowed. And let's just say for this one, for example, HTTP is disallowed. And what this basically means is that if there's a call coming in at port 80, which is the HTTP port, it will be denied. However, if it came on port 81, this rule, number 1, would not apply to it, but the second one would, because all traffic includes all traffic, and that would be allowed through. And if we were to switch these, like make this 2, that 1, then what would happen here is that rule 2 would effectively become worthless because it would never reach there. Okay, but let's actually add a rule here. So HTTP, no, we're going to do all traffic. Everything is allowed. Go to the outbound rules. All traffic is allowed. Excellent. Before we get into the NACL example, I'm going to explain to you what the three-way handshake is by just using a really quick graphic. So when TCP connection is actually TCP IP connection is being created, the client is going to send a SYN, like you see right here, to the TCP server. And the TCP server is going to send back a SYN awk, and then the client is then going to send back acknowledge to let the server know, like, hey, I'm acknowledging this connection. This is the three-way handshake that you might have heard of. Okay, pretty simple. And this is important because we're going to talk about a network utility called tcpdump, which is a Linux packet sniffer. And you can use it for several different protocols, but we're going to be using it for TCP and UDP in this video. So I'm going to install some helpers with me because TCP dump is already on here. Dump. Yeah, already there. But we're going to do sudo yam install tmux -y. And what tmux is a Linux multiplier. So that essentially means, in layman terms, it creates windows for you within your session. Actually, detached from your session. That's running independently of the main session. So when you log out of the shell, it's still running in the background. All right, already installed, and it should already be installed in here as well. I think I already pre-installed it. Okay. So we're going to do tmux, and that's it. Now, and how I did that on Windows, it is Control B, and it should be the exact same thing on Mac as well. Do Control B. So it'd be Control B, and that's the prefix, and then you do Shift double quotations, and that'll split the screen horizontally. Then up here we're going to do tcpdump -I, which I just means to specify the interface you actually want to be monitoring. And I'm going to say any because there's only one interface actually attached to this EC2 instance. Well, network interface. And next, we're going to be listening on a specific destination. So the destination is going to be this IP address up here. Or the source being that, /n, and -n just means that instead of using names, we're going to be using IP addresses in the output. Okay? And this isn't going to work unless we do sudo okay. Now, to go back down to that lower window, what we're going to do is do the prefix again, which should be Control B, and then press the down key. All right. Now we're going to start up a new TCP server on port 80. Then come up here. Port 80. All right, let's first take a look at this output. What you're seeing right here is the timestamp of which it occurred, followed by the network protocol, which is IPv4. If it was IPv6, then it would be IP6. Then followed by the source IP and port, followed by the destination IP and the port. And here it says HTTP, although HTTP is port 80, then followed by the flags. And so do you remember the handshake? The flags represent what part of the handshake we're in for TCP. So for S, that means SYN. So let's bring that info back over here, the little image. S means SYN. S period means SYN acknowledge because period means acknowledge. And then you're seeing that acknowledge again down here for this third one, acknowledge. So the connection has been established. Okay? See that? We're good. Now let's actually send something. Send. All right. So now you see P acknowledge. P stands for push data, and you can see the data has a length of 5. And the reason why it's 5 and not 4 is because there's stuff with other parts of the packet that is also thrown in together to actually be routable to this host. So it's a payload plus some other stuff like the metadata. And then you see the acknowledge again, saying that it's done getting the transmission. But let's also take a look at the destination and source. So from here, this one is sending the data, but then followed by the foreign server talking back to the client saying, hey, acknowledge that we have the data from you. There's always the acknowledge after a send. And so let's kill the connection. Okay, connection is done. F means closed or finished. Okay. So with all that in mind, actually we can leave this big because we're mostly going to be looking at this. So right now, all traffic is open, as you just saw. Let's go down to our next example here. And what if we made it where only SSH was allowed? So SSH for inbound and SSH for outbound. Can these servers talk to each other? Can we actually still SSH into this host, or is it going to give me trouble? Hey, so it looks like I forgot to actually associate the subnet to the NACL. So let's go ahead and do that real quick. Everything will still apply because everything was open beforehand, but let's just go ahead and do the association. So you come here to actions, you go to edit subnet associations, and we're going to do this last one right here. We're doing this one because the foreign instance happens to be in that subnet. Let's close that. Foreign should be down here. Yeah, right here. Subnet C12. That fits. Okay. So this, you can see that we have inbound for SSH22 and SSH22 going out. And I'm pressing enter, but nothing's happening. The reason why this doesn't work is because when we make the connection to the foreign server, we're connecting to port 2022, right here. However, what's happening is that the port that the foreign server is going to be responding to is not port 2022. It could be port 38,561, for instance. And so this will unfortunately not work in our case unless we were able to actually map whatever port we open or the client's running on is on port 2022, which you shouldn't do that. So let's make this all traffic. And now we can connect back to it. Clear. Hey, so let's work with our next example. So we're actually going to change this SSH inbound rule. We're just going to make this all traffic. Confirmed. And we're going to go to outbound, and we're going to change this to where all traffic is allowed. However, we're actually going to still keep that 1, that 2, all traffic, but we're going to block port 80. Deny. Clear and clear. Let's go into our tmux session. Okay. Still, that's correct. Excellent. Okay. So let's try connecting to this. So we're going to do sudo nc-l 80. Yeah, 81 doesn't exist. Okay. Hello there. What's up? And let's take a look at the traffic. As you can see here, where the connection's coming from, it's coming from the U server on this port, talking to the foreign server on port 80. And that looks like it's using the private IP to represent this home server here. And it's pushing the packet. Okay, great. That works. So let's actually modify this command right here. And we're going to make it where we can specify the port it should be coming from. And we're going to say the port that should be open to communicate with the foreign server is going to be port 80. And we have sudo there already. Good. Take a look at the output here. See what's happening here? Okay, connection timed out. And the reason for that is pretty much the same reason for why SSH failed. It's because, well, yeah. When the server goes to respond back to the U server, when the foreign server goes to respond back to the U server, it's respond back on port 80. And as you can see here, port 80 is denied on outbound, so it can't respond back. However, you can see the connections coming through here. Let's go up to the top. It keeps saying SYN. It's receiving SYN. And it's trying to reestablish the connection. Connection reset. So R means connection reset acknowledge. And it can't actually do that. And And that's just because you can't respond back on port 80. Let's start this up again. And we should see, oh, should quit. Yeah, we're trying to see that SYN and the SYN acknowledge. The reason why we're seeing connection reset is because we already had a pre-existing connection there. Okay, and that's now dead. Okay. But if we were to flip this in reverse, nc sudo nc -l80 and down here we had wow, sudo nc it's still going to fail. Why? Because it's still saying outbound to port 80. It's not going to work, unfortunately. So it can't respond back to port 80, and it cannot contact port 80. So there would be no HTTP heading out. But if we were to change this port to port 81, as you can imagine, this now works. Okay, awesome. Now let's flip it, and let's do for inbound, we're going to change it to where port 80 is deny, all traffic is allowed. Make this 5555. No particular reason, just to show y'all that it works. Okay, at outbound rules, we're going to remove this, leave that as 2. All right. Now, let's have this one host again on port 80. And let's see if we can communicate with this. Oh, let's put -v back in there. Okay, seeing that there wasn't a connection immediately, this is going to time out in just a second. Yep. And if you were to change up the port to port 81, you can tell that's also going to time out in just a second. There we go. And that's because all inbound to port 80 is now closed. You shouldn't even see it here. Yep, doesn't make it to the host at all. Now let's come down here and let's flip it and reverse it, where this is now going to be hosting. Connection can be established because outbound, remember, everything is now open. They can now talk. Same rules apply, so let's actually change it to where the port is now 80-V. Start that back up again. See, it's trying to connect to it. Saying send, but it can never get out because the firewall, the NACL, is blocking access to this particular host. So it's going to retry a little bit and the connection timed out. It doesn't work. Okay. And let's also talk about some other protocols here real quick. So you see HTTP, but there's also POP, IMP map, LPAP, HTTPS. Another one is going to be UDP, which is probably going to do custom UDP. Protocol, port range. It could be 55, for instance. You can block it, allow it. It follows pretty much the exact same premise as TCP. Where, like, depending on like the inbound, outbound rules, will determine whether or not you actually can communicate past that firewall. But yeah, but that's security groups and stateless NACLs in a nutshell. Thanks for watching.